Michelin makes tyres. Lots of tyres. For just about anything with wheels. Cars. Trucks. Motorcycles. Tractors. Giant earth movers. Jumbo jets.
Now under 1 minute to go in Atlantis' flight.
And the space shuttle.
Now on final approach to the Kennedy Space Center. Gears down and locked.
It all starts here, in Clermont-Ferrand, France, at Michelin's original Megafactory. Few people ever get inside a Michelin factory to see how they make their tyres. That's because tyres are big business. With lots of secrets.
We invest heavily into research and development, over 550 million euros every year. We have increased the amount of patents that we've generated, over 240 patents a year. As an American, I would say you're in the Silicon Valley of the tire industry.
Financial stakes are huge. In 2010, Michelin's net income topped 17 billion euros.
We take as many measures as we can to try to protect our competitive advantage.
To compete, they hire experts in over 200 fields. Everything from chemistry to machine automation.
In the mind of people, tire is very simple. It's a piece of rubber that potentially you put in a mold, you cook, and everything is fine.
But making a modern-day tyre is practically rocket science. They start by combining rubber, steel, and synthetics into more than 200 components.
We will have several layers. We start here with the first one, which is a layer which prevents the air to go outside the tire. And that's a specific type of rubber that we use. The main deal here is to keep the air inside the tire and have no leaks.
They feed the different materials onto a drum and splice them together.
It's very important to cut very well, and the joint is also extremely important.
They roll strips called bandelettes around the tyre, which act like strands of heavy-duty packaging tape, holding all the layers together.
To make a tire round is very, very difficult.
All the different layers must be cut and aligned perfectly.
He's using here a little bit of liquid to make sure that everything sticks together very well. seen here two different other bands. It's going to be a mix of product to really make the core of the tire, but also a few bands to protect specific areas where the shear and the stress is very important. The tire needs to function for many, thousands of miles.
Tyres are under stress just holding up the weight of your car. That stress increases when you corner. Accelerate. Or brake hard.
In fact, all the forces between the car and the ground are due to the tire. The most incredible thing with tire is how the tire is important for the performances of the car, because for a lot of people it's just a black part.
Tyres, any tyre, is a highly engineered, complex part of your vehicle. Some can make you feel like you're flying. Others are specially designed to get you airborne. Michelin makes a lot of different tyres. And they're all manufactured using similar methods.
Here you start to see two bands which are going to be receiving what we call a tringle. These are the steel circles that are used to keep your tire on the wheel. We are using a pneumatic piece to bring back part of the tire. You will see that it's kind of strange. The first part of the building, the tire is not round, it's just flat. That's how we build it and make sure that all the layers are very well put together. These two bands here are the sidewall, okay? So you see that here it's flat, but later on we will inflate and you will see the tire really taking its shape.
But first, more rubber. And more bands.
We put what's needed in terms of rubber, but not too much.
Still more layers. And a modern twist.
Barcode, very important to trace. So as you've seen, so you know exactly who did it, when. So later on we can have the history of really the tire throughout the plant, but throughout the life later on. We're going to put on the second machine to start the second stage, which is really building the top of the tire. So we can work now on an object, I would say, which is much closer to what you imagine a tire to be.
One key component in a modern radial tyre is its steel belt.
Again, some small bundle-ups to make sure that you protect the tires against the stress.
They place a long, thick piece of rubber on the industrial version of a hot plate. softening it before rolling it around the tyre.
You start to see the tread, which is really what you see every day. We're going to pretty much finish the job by pulling back the sidewall that you've seen, okay? So you put it on the side so we could put the inside the plies together. And now we are finishing by pulling back the sidewall piece of rubber on the top of everything. You know, we have the feeling that it's one piece that you put on your car. No, it's a combination of many different pieces put together, but very well.
To determine how well, they head to Michelin's Research and Development Centre, where maximum security rivals that of a prison. Getting inside Michelin's Research and Development Centre isn't easy. They take your passport, give you a computerized card to track your every move, even check your vehicle before they raise the gate.
We're very serious about protecting our know-how, protecting our ideas.
About 3,400 people work here. Some test on the track. Others in the lab.
This is the largest research and development center in the Michelin Group. About 75% of our major innovations are studied here.
We are in a building where we study all the relationship between tires and cars.
A huge drum recreates the temperature changes generated by the friction of the rubber against the road.
One of the very important tests is safety, endurance, and we do that on the machines. They are almost torture machines. We put the tire on extra load, extra heat. Everything is extreme, but to make sure that they will resist.
A smaller machine simulates the pressures the tyre faces on the road.
It's very important to understand how we can adjust the tire materials, the tire construction to optimize that contact under all conditions.
Meet a tyre's worst nightmare.
put it through a torture test, run it in overloaded, overheated conditions to put it through its paces.
This machine can make a tyre scream in pain.
The tire is a perfect example of an engineering compromise. It's very easy to make a progress in one performance area, very difficult to make that progress and not trade off in the other areas. For example, we can improve tire wear. We can double the tire wear life tomorrow, easily, but there may be implications on the appearance or noise characteristics that are not acceptable.
This room tests nothing but noise.
The noise emitted by tires, the contact between tires and ground, is between 50 and 80% of the global noise emitted by a car.
Two huge doors help keep all external sounds out of the room.
The noise is produced by the air going throughout the treads.
Inside your tread pattern there is some rubber edges. So you have shocks of the edges against the road. So that creates noise. So you have a lot of air going through with small vibrations of the rubber, and that creates what we call an organ pipe noise, like in a church.
They run the car up to maximum speed. Special acoustic materials on the walls keep the noise from bouncing around the room. The only sound left is the sound of the tyres. Now it's time to mount the tyres on a car.
And when all the testing is done on the machines, we pick up the solution which are the best for the different elements, safety included, and we put on the car for the final battery of testing.
And that happens here, at the Technology Centre. On a high-speed circuit. A dry handling course. different wet handling tracks. "19 different tracks in all, totaling 41 kilometers.
Well, here you have an image of what you could see if you could be under the road and looking up at your tire.
Where we're able to make precise evaluations of the actual contact patch between the tire and the road surface.
So if you want to describe the contact patch, it's pretty much how much of the tire touches the ground, where the action takes place. Everything takes place on pretty much the size of your hand. That's pretty much the contact between your vehicle and the road.
A high-speed camera under the glass in the track captures real-world pictures of the contact patch in action.
That's where all the forces pass for the control of the vehicle, for the braking and acceleration. Everything passes in a contact patch that represents about the size of a postcard. For us, that's a key laboratory because the contact between the tire and the roadway is absolutely crucial.
After each pass, the underground camera image appears on a monitor. The result? A real picture of a contact patch. A split second of time. Captured to study. To learn what's really happening between your tyres and the ground. They run as many as 100 passes in a day. A final check on tyre pressure. And another test begins. But not every test is done at high speed. This one starts at 31 kilometers an hour and goes down to 0. This race could literally change the future of tyres.
So we are on a track which is for today dedicated to rolling resistance testing.
Rolling resistance is the friction of the tyre against the road. In this race, the car that stops first loses.
So we have the two cars side by side. We have put the cruise control. We are at 31 km per hour. So here we are, neutral gear. I'm cutting the engine off, and we just wait.
For a normal passenger car tire, for example, the rolling resistance of the tires can consume 20% of the energy required to operate the vehicle.
The white car is testing a new tyre, designed to lower rolling resistance.
Here we are. We have stopped now.
It's a significant victory.
Essentially, 1 fill-up in 5 for fuel is due to overcoming just to make the tires roll. And on a heavy-duty truck, it's even more significant, 30%.
They know, because they race trucks too. The blue cab truck is using tyres with lower rolling resistance. Both drivers shift into neutral and wait. The race is on. It's a convincing and important win.
So the tires keeps a part of the energy. So our work is to minimize that energy losses. We do that through new materials with less losses.
Most tyres Michelin makes emphasize lower rolling resistance.
The next step is we're going to have the tire to rest for a while, even in a temperature control room. And then the final step is going to be the curing. So curing, then again resting, final control, and be ready to go.
Time and temperature inside the mold vary on how big a tyre they make. Some of them are very big.
Mold is several sectors, we say, or pieces of steel, which are engraved with information about your tire. And then that's where the tread pattern is designed, and you will get the shape of your tread pattern.
Michelin ships its tyres all over the world for all sorts of vehicles.
Process is the same all over the world. So Michelin tires made in Clermont-Ferrand, France, in China, in North America, you will get exactly the same quality and the same performance.
One of Michelin's highest performance tyres is for one of the fastest production cars in the world. The Bugatti Veyron Super Sport. Its tyres are capable of sustained high speeds of over 400 kilometers an hour.
Everything here will be made based on laser, very, very precise rotation.
The process Michelin uses to make a Bugatti tyre is a bit different than the one they use to make a regular car tyre. Regular car tyres use more machines supervised by workers.
When we talk about innovation, when we talk about technology, this is the proof here. It's much more technological than we think. That's a tire for an Airbus aircraft. That tire is capable of incredible things. And what's interesting here is that in one piece you have almost the capability of a NASCAR or Formula 1 tire, because it needs to roll pretty much 200 miles per hour when you land. It needs to carry several hundred tons because you've got your aircraft, the passengers, the load, and you need to resist for temperature variation between minus 50 degrees Fahrenheit and roughly 100. When you land and you've got the contact with the ground, boom, you've got great increase of temperature. Like every other tire is round and black.
Michelin's bottom line is performance.
You can increase the performances of the car in a very, very large way with the tire. Enter on the track, the name is the number 1. The track is 8 kilometer length.
This track is for testing high-speed maneuvering.
I control 3 parameters. Okay, the speed of the car, the steering speed, very fast. Now we are at 230, 240. Okay, we are at 250. And I do some lane change like this.
Lane changes let the test driver compare one tyre design against another.
When I compare 2 tires, I will do exactly the same maneuver on the same place.
Lane changes like this could get you arrested in the real world. But they push the tyres even harder. Michelin wants to rule the tyre industry. So when they take high-performance cars into full race mode against fellow tyre makers, Michelin wants to win.
There's been a lot of competition recently with our high-performance tires. The high-performance requirements are very specific. However, there will be learning from those programs for the regular vehicle.
On regular cars, some people never check the air in their tyres. But here, they do it before every test. Each tyre is designed to provide its maximum performance at a specific tyre pressure.
This is a braking test on dry ground with identical vehicles, but with different tyre pressures.
For this test, The silver car has overinflated tyres. The dark grey car's tyres have the right amount of air.
So, the distance between the two vehicles is almost a vehicle length.
A difference that could mean a safe emergency stop. Or a disaster. On this test, it looks like a disaster could happen any moment. Watch the rear tyres.
We can play here on the tracks, but not on the road. This track is wet. It's polished concrete, very slippery.
The truck with the blue cap has different test tyres that work better on wet ground.
Just in front of us, you have the first truck, which is losing control.
It keeps sliding. Both drivers maintain the same engine speed. But the blue cab truck doesn't slide.
Now it's very easy. If you look at my colleague with the first truck, he's working hard. And for me, I can drive only with one hand.
The better tyres are winning.
You see, we can go much faster than him.
Michelin doesn't wait for rain to test its tyres in the water. Sprinkler systems create anything from a drizzle to a downpour. And then things get crazy. Fast. From supercars to station wagons. Every new tyre design gets to play in the rain. And mud.
Ici, nous sommes sur l'hydro.
This is called the hydro track. We're trying to test the top speed, the maximum speed at which we lose grip on the road. To perform this test, we increase the speed of the vehicle. We start at 40 kilometers per hour and we increase it by 5 kilometers per hour every lap.
They push the limit until the tyres lose traction.
The tricky thing on a regular car is that when you design the tire, you have to imagine any kind of conditions. Rain, ice, bumping on a curb.
The next water test is probably something everyone's experienced on the highway. Driving next to a big rig in the rain. Suddenly, you can't see a thing.
When you are driving just close to a truck with your car, you receive a lot of water on the windshield and a lot of water also on the ground coming from the truck. And that is very dangerous for the cars. When you are driving in water, you move the water and you create something like a wave. So the idea was to suppress the water splash from the truck, just changing the shape of the sidewalls of the tires in order to avoid so much water going through the windshield.
This truck has the new tyres. Watch how changing the orange truck tyre shape makes the wave become a splash.
And you create just a small movement of water close to the ground, suppressing the big splash.
There's a simple reason that Michelin spends time and money to make tyres splash less.
Our future depends on our ability to compete.
Testing never stops.
Antoine, pour F20, j'aimerais aller sur le numéro
1. Michelin keeps building tyres. Lots of tyres. For just about anything in the world with wheels.